Hi, it's Zoe from Seneca, and today we're going to be talking about relationship of bonding to properties. Cool. So, solid structures. There are four key types of solid structures. Number one, giant covalent, one of the two possible structures formed by covalent bonding. For example, diamond. For example, graphite. Not as cool as diamond. Number two is metallic. This form of crystal is seen for pure metals, for example, magnesium or sodium or aluminum. And the next one, number three, is molecular. One of the two possible structures formed by covalent bonding, for example, icy, and iodine. Number four is ionic, formed by compounds of metals with non-metals. Any salt is a good example of this structure, such as sodium chloride, magnesium chloride, or lithium bromide. All great examples. Okay, which of the following pairs of compounds and structures are correct? Graphite is a giant covalent structure. Solid iodine is a molecular structure. Yes. Magnesium has a metallic structure. And ice is a molecular solid. Okay. Ionic crystals. Ionic crystals have strong electrostatic attractions between the ions. This leads to high melting points. The ions are fixed in place, so ionic crystals cannot conduct electricity as a solid. The ions are charged and so are soluble in polar solvents like water. In solution, the ions are mobile and can act as charge carriers. In solution, they will conduct electricity. Giant covalent crystals. Giant covalent crystals have strong covalent bonds throughout the entire structure. This leads to high melting and boiling points. Note, many giant covalent crystals will sublime, which means skip the melting point and go straight to a gas. Well, through the melting point, but skip melting and go straight to a gas, which I think is pretty cool. Giant covalent structures do not dissolve in anything. Not even anything. Metals consist of a sea of free electrons surrounding positive ion cores. The strong electrostatic attractions mean metals have high melting points. The melting point of a metal depends on the number of free electrons that it donates to the sea. The free electrons allow metals to conduct electricity as a solid. Metals can also conduct electricity as a liquid. Metals do not generally dissolve in water. This is because many will react with water to form metal hydroxides. And lastly, molecular solids. Molecular compounds have very weak intermolecular forces. They have low melting points and are often liquids or gases at room temperature. Weak performance from them. Iodine is a solid at room temperature, but chlorine is a gas, for example. They do not conduct electricity. Some molecular solids may dissolve in water, but many will not. This is discussed later in the session on polarity, so hold that thought. Okay, molecular solids and covalent structures are very different. This is reflected in their properties. So, molecular solids. Molecular solids are held together by intermolecular forces. Intermolecular forces are forces between molecules that are not, I repeat, not bonds. These forces are fairly weak and easy to break. In melting or boiling a molecular solid, the intermolecular forces are broken, but the strong covalent bonds are not. Giant covalent solids, however, in giant covalent solids, the entire solid is one molecule. The only forces present are intramolecular forces. Notice the difference between intermolecular, which means between, and intramolecular, which means within. These forces are otherwise known as covalent bonds. Intramolecular forces are much stronger than intermolecular forces. This means that giant covalent structures have much higher melting points because covalent bonds must be broken. And that's hard to do. Which of the following are true for molecular solids compared to giant covalent structures? The answers are: they break intermolecular forces on melting, you have a lower melting point, and solid in many... Oh, the solid is many molecules as opposed to just being one molecule. Okay, giant covalent structures. Within the structure, there is an extensive network of covalent bonds that must be broken to melt the solid. And lastly, the 4 types of solid structures are giant covalent, molecular, ionic, and metallic. Okay, that's it. Give yourself a round of applause, pat on the back, whatever it is. We'll see you on the next episode, and thanks for joining. Bye.